Okay, let me introduce the third assignment. In this assignment, we explore the heap data structure by building our own custom heap, comparing it to Java building in priority queue, and apply it to a real-world scenario involving post rank. We use the dataset of the 10,000 posts and develop an efficient way to select the top 10 most viewed posts. Let's imagine a platform like a blog or a forum. Every day, thousands of posts are published or tested to identify the 10 most viewed posts from a largest dataset. Sorting the entire dataset would be inefficient. Sorting 10,000 items takes O n log n time. Instead, we used a heme structure to reduce the complexity to O(n). Each post in our dataset has a unique ID, as you can see, a post ID and a view count to store in the CSV file called post CSV. And our solution for selecting the top 10 posts is in the top 10 posts Java file. We use the Java priority queue, as you can see here, to implement a min heap. You can see here that only keep the top 10 highest view posts. We can walk through this main step, and first we will need to create a min heap with a capacity of the 10. Um, the comparing post by the view counts. And then we will read the CSV file, as you can see here. We skip the header and extract each post ID and view account, as you can see here. And then if the heap isn't full, as you can see, the size wasn't to the 10, we add the post. If it is, we compare it with the smallest and replace if needed. We will print it out after we test it. As you can see, we can test through this one. Then we got the result. As you can see, we got the post ID and the view account, the top 10. And now let's take a look at the MyHeap. As you can see here, or custom implementation of the binary heap. This heap support generic types and can be used as either a min heap or max heap. We used an array list to store element and implement add and pull and pick operation. As you can see here for the constructor, this customer, the comparator decides the order of the element, give us flexibility, and the offer and the pull method. This method use helper function, shift up and shift down to maintain heap order. And for the shift up and shift down, as you can see here, are the heart of the heap. They make sure the smallest or the largest element is always at the root. The shift up is used after insertion. It pushes the element up and the tree until the order is valid. And the shift down is used after the removing the root. It pushes the elements down the tree to restore order. And we can test the performance of the heap against the Java priority query using 1 million insertion. As you can see, 1 million insertion and the deletion result will store in the test result. As you can see, we can run this test. Yeah, let's run these tests. Yeah, and we can get the result here. Sorry, let's run the test again. Yeah, you can see here. So as a result, the building in priority queue is faster, but our implementation is still within reasonable performance for the real world use. To warm up, this assignment give us a deep understanding of the heap data structure. We implement our own generic heap, use it to solve a real world scale problem, and benchmarked it against Java's standard library. Yeah, thank you for your time to watching this.